Welcome back. Another day of asynchronous learning. Today's lesson is 1.3, operations, and that's operations on the real numbers. I hope everyone is doing well today. This is a very straightforward and basic lesson. The keywords are sum. You need to have a working definition and be able to explain what these words mean, even if it's in your own words, preferably in your own words. What is a sum? A difference, a product, quotient. What are factors? I make this a little bit easier for y'all. The dividend is what you're dividing into, while the divider is what you're dividing by. And then you need to be able to distinguish and know the difference between these three distinct words: opposites, inverses, and reciprocals. We will talk more about those three words because they are commonly interchanged or used synonymously, and that is incorrect. These are not synonyms. They have distinct meanings. All right, we're going to start off today's lesson with absolute value. And I want to hopefully incorporate a new definition or understanding of absolute value using your previous knowledge. So let's start with absolute value. These are the symbols right here for absolute value. And what we've learned in the past, that the absolute value is simply the distance a number is from 0 making this quantity always, be careful, I know you want to say this one word, this quantity is always a blank, a hyphenated word, number. The word that you might lean towards, and it's not the best word to use in this situation. Some people have learned this is always a positive number. Well, no, it's not. It's always a non-negative number. What's the difference between non-negative and positive? Well, positive does not include one of the most important numbers out there, the number 0. If I say it's always a positive number, we're excluding 0 from our answers, and that's not going to happen. We cannot do that. We need to include 0 in there. We need anything that has 0 or bigger than 0 in its set. So we use the word non-negative numbers. Basically, some people mistakenly think that you change the sign of absolute value. You don't. All you do is drop all signs. You're going to make sure that whatever you do, whatever's inside of this absolute value, after you do all the work and get a single quantity, then you take the absolute value of it. And we'll look at that a little bit closer. So here we go, continuing on this little journey here. Let's find the absolute values of these following numbers. What's the absolute value of 9? The absolute value of 9 is 9. What's the absolute value of negative 9? Well, the absolute value of negative 9 is also 9. If you graph these on the number line and then just counted straight up, not worrying about the direction you were headed, whether you were headed up, down, left, or right, if you just counted distances, how far is 9 from 0? 9 units away. How far is negative 9 from 0? It's 9 units away. Now, what happens when we put that negative sign right outside the absolute value? Well, that means we still take the absolute value of 9, which is 9, and then we make that answer negative. This is equal to a negative 9. Well, for some of y'all that are asking, I thought that it always had to be a non-negative number. You are right. It always has to be a non-negative number. But this means I am now creating it such that it will be a non-positive number. This ensures that we have non-positive numbers. Same here. Now don't do this. Do not, let me see if I can do this. This is horrible to do. Never distribute. That's still on screen? Yeah. Never ever distribute the negative sign into the absolute value bars. You cannot distribute it in there. These are like parenthetical grouping symbols. You have to do all the work inside first, then work your way out. This again, the absolute value of -9 is 9, and I want to take the opposite of that. I want to make this a -9 as well. If you do not understand what I just said here, get with me as soon as possible so that way I can explain that to you again, maybe in a different way. Now, here's what we were talking about from this definition. This quantity is always a non-negative number. If we're taking the positive absolute value of stuff, the answer is always going to be a non-negative number. If we're taking a negative absolute value of something where the negative sign is outside, right out front of that negative value, think of it as a -1 times whatever that quantity is. So you're just taking the opposite of it. Getting down to this little neutral number here, what's the absolute value of 0? It is still 0. There's no such thing as positive or negative 0. It is the only number that does not hold a positive or negative sign. You can think of it as a neutral number. All right, so now we come to this problem here. The absolute value of -9 plus 3 minus 4. Do not take the absolute value of each number individually. You have to simplify the inside first. How do you simplify the inside? It's easy. Put these two numbers together. Put all your negative numbers together and then all your positive numbers together. -9 and -4 equals -13 plus 3. -13 plus 3 equals -10. Notice I'm bringing the absolute value each and every time. Now that I have a single quantity, -10, the absolute value of -10 is a perfect 10. All right. Let's talk about double negatives. Here's how we handle double negatives in any math class from kindergarten up to differential equations. If you have a negative number inside a set of parentheses with a negative number outside of it, it can be distributed like we do here. This is not only okay, it's what you have to do. So this can be read as a -7, and that double negative, it's almost like a negative, no, it's not almost like, it's exactly like a -1 times a -7. -1 times -7 equals +7. Think of it like this. Instead of thinking of this as a negative number, you can think of it as the opposite of -7 is, and that's all we're doing. The opposite of a -7 is a +7. All right. Let us take a peek at the 4 basic operations of arithmetic. Now, this word can be pronounced 2 ways depending on how it's being used. If we're using it like a noun, in this case, we say arithmetic. If it's used as an adjective, then we call it arithmetic. We've had arithmetic and geometric sequences before in previous classes, so make sure you're pronouncing it the way it's supposed to be pronounced. In this case, it's basic arithmetic. When used as a describer or an adjective, we call it arithmetic. Jumping into example 2, what do I want to do? Oh, I want to talk about the additive inverse property first. What can we add to a number so that way here's what inverse means. I think of this 4-letter word. An inverse undoes something. So what's the inverse? Notice I'm not using the word opposite, I'm using the word inverse. What's the inverse of addition? Subtraction. What's the inverse of multiplication? Division. What's the inverse of a power? You can either say a root or a logarithm. Bringing back those logs real quick to you. All right. I am going to actually need you to tell me what the opposite of A is. The opposite of A is negative A. These two numbers are going to cancel each other out. But you need to make sure you understand what it cancels out to, because sometimes when you operate with these numbers, they cancel out to 0. Sometimes they cancel out to 1. When we're dealing with addition or subtraction and we add the opposite number, we are trying to undo what we're trying to do here, or what they ask us to do. We're trying to undo or get rid of this A, and this will cancel, or this actually will cancel out to 0. What I'm doing, I'm making kind of a big deal about something that's so basic and so easy. All right? What we mean to say here is whenever you're trying to solve an equation and you have some constant on one side of your equation that you're trying to get rid of, just add the opposite of it, and that is called the additive inverse property. That helps undo what you have going on here. You know what? Too much words. Let me just show you some actions. X plus 4 equals 9. How do we solve this? We are going to add the opposite of this. Well, you just learned it as minus 4 on both sides. All right, that'll work. What we're adding is the opposite of this, or what we're trying to do is inverses here, so that way they can say bye-bye birdie and go out to 0. X is equal to 5. That's the whole point of this. Without actually knowing the name of it and why it works and how it works, it's kind of illegal for us to try to be able to use things if we don't even know how those tools or properties or operations work. Here we're just going to do some simple math. How do you add integers, or how do you add real numbers? Well, if the signs are different, you actually subtract the numbers and keep the sign of the larger number. So I'm going to say 13 minus 6 is 7. 13 looks to be the bigger number, not just because it's positive, but if I take the absolute value of these, which one would be bigger? It'd still be the 13. And 13 happens to be positive, so my answer is going to stay positive. If the signs were reversed, if this was 6 plus negative 13, this would just become a negative 7. Very simple, very basic. What if the signs are the same? Same signs? Oh, that's easy here. If you're adding two numbers that have the exact same sign, both positive or both negative, just add the numbers and keep the sign. Oh, some of y'all are like, Mister, what are you doing? Why don't you just put this in a calculator? No calculators on your first test. Little smiley face there. I have made sure that the operations or numbers are pretty basic and straightforward, so we want to make sure that you're just not punching this into a calculator. Can you actually do this without the aid of a calculator? Can you do this? Do you have the brain power to know what to do with these numbers? Like this right here. What did we say to do when the signs are different? We actually subtract them. I'm going to take the one that looks bigger, the 38.4, put it on top. I'm going to subtract 2.51 from it, and it's done something like this. Old school math, y'all. Let's make this 10 and 13 and 7. I don't know how you learned how to do it, but that's kind of the way I did. So 10 minus 1 is 9, 13 minus 5 is 8, 7 minus 2 is 5, and anything else? No, that's good. 35.89. Now, keep the sign of the larger number, the one that looks to be further from 0. We're going to keep the negative sign. This is going to be a negative. Why did I not give myself enough room? Let's write it down here. Negative 35.89. Now you have some options here. Let me see how bad this looks. I'm going to try it one time. Can you either highlight your answer, circle your answer, or box your answer? I need you to do one of those three things. Identify what is your final answer. Don't make me search the page for what the answer is. I know that's a tactic that some of us use at times. I'm not sure exactly what the answer is. Let me just leave it blank so that way hopefully my answer's somewhere on there. No, guys, don't do that. I don't want to go on any type of scavenger or treasure hunts. That's not my job. I need to make sure that you all box your answer so that way I can find it quickly and easily and move on. So that way I can get your stuff graded and back to you in timely fashion. Fractions. So many people have a fear of fractions. Don't be afraid of fractions. Fractions are your friends, all right? What you need to do is a common denominator. What you need to find or create is a common denominator. Out of 5 and 4, that common denominator is 20. So I'm going to go ahead and multiply this first fraction by 4 over 4. That's a fancy number 1. I'm going to multiply the second fraction by 5 over 5. That's another fancy fraction. That's going to leave me something like 4 over 20 plus a negative 15 over 20. Oh, I know what to do. Watch this. Always thinking on the fly, always being able to improvise, adapt, and overcome instead of squeezing it in there. Everything good there? Yeah, everything's good. 4 plus negative 15 is the same as 15 minus 4, which is 11, but let's make that a negative 11. Negative 11 over 20 is our answer. Ooh, did you see how we just turned that line into a fraction bar? It isn't too exciting, but it is to me. Always being able to improvise, adapt, and overcome. All right, one of the Marine Corps mottos. Here we go. Subtract numbers. You have one of two options when you're subtracting. Remember, we're doing this without calculators now. You could think of it like this. What is subtraction? Subtraction is just the inverse of addition. This is the same thing as a negative 7 plus a negative 3. So if the signs are same, add the numbers, keep the sign. That's nothing more than a negative 10 right in front of your eyes. All right, what to do when we have this right here? Remember what we said. As long as this is not an absolute value bar or a radical symbol, if all it is a simple parentheses or a bracket or a brace, like a grouping symbol for this, then we go ahead and distribute that negative. What's the opposite of negative 3? It's a positive 3, so this becomes negative 7 plus 3. Signs are different, subtract them, and keep the sign of the larger number. Piece of cake upside down. When you have a little number minus a big number, remember it's the same thing as this. 99 minus 48. That equals 51. But little minus big means your answer is going to be negative. Again, this could have been thought as 48 plus a negative 99. Nobody likes to write it this way, at least nobody that I've met in the past 20-something years. They don't like to say 48 plus negative 9. We just like to say 48 minus 99, not 48 plus negative 99. All right, decimals. When you have decimals, just be very careful. You know what? Not even. Oh, yeah, always be careful. But think of things that you already know about. What do you know about here? What does this look like to me? It looks like money. So let me go green on this one. This is like you owed somebody $7 and all you had was a couple pennies to give them. You're giving them your 2 cents. Dad joke. What is $7 minus 2 pennies? It's equal to $6.98. Now, go back to what we talked about over here. Little number minus a bigger number means your difference in this case, the answer to a subtraction problem, the difference is going to be negative. I hope that helps. It does. And get used to, man, I still tutor kids that I will ask them what is, in this case, I would have asked them, what is 7 plus 3? And they're like, oh, hang on. And they're looking for a calculator. Don't be that person. All right? Practice, even if you're not good mentally in math, and just write them off to the side. Do a little side work. All right. Last thing I want to wrap up this lesson with is, oh yeah, they have a whole bunch of way of saying these. When you're dealing with multiplication or division, here are the rules. Very simple, very easy. What is a positive times a positive? A positive times a positive equals a positive. A negative times a negative equals a positive. A positive times a negative equals a negative, and a negative times a positive equals a negative. Same exact rules for division. Now, what happens if you have more than 2 numbers that you are multiplying or dividing? Oh, by the way, I just want to say this real quick. What do I mean about that then? So I don't have to rewrite it all over again. A positive divided by a positive is a positive. A negative divided by a negative is a positive. Positive over negative is negative. Negative over positive is negative as well. Now, let's say that you have more than 2 numbers. Let's say that you have 3 numbers, 4 numbers, 5 numbers, 10 numbers. If you know the number of terms that you are that you are multiplying or dividing in this situation, just know this. If you count the number of signs, the number of negative signs rather, that's kind of going to determine what we do. Right here we have 2 negative signs. 2, an even number. A negative times a negative is a positive. If I throw one more negative in there, a negative times a negative times a negative, if I have 3 negatives, an odd number, then here's what we're going to do. If it's an even number of negatives, your final product or quotient is going to be positive. If there is an odd number of negative signs or an odd number of negative numbers, then the final result, called a product or a quotient, will be a negative. Let's talk about the multiplicative inverse property. Oh my goodness, I'm so sorry guys. That was a little off the page there. Let me give you a sec to catch up. I need to have a little piece of tape on here to keep me in the lines. I'll pay more attention. I'll leave it right there so y'all can see that. Okay, the multiplicative inverse property. This is a fancy word for reciprocal. Think of reciprocal. All right, and if I have the number A or the quantity A and I want to get rid of it again, like 3A equals 12. I know a lot of y'all know to do this, divide both sides by 3, but let's see why. 3, here's why that works. 3A equals 12. What we're actually doing, this is the fast way to do it, divide both sides by 3. What we're actually doing is multiplying both sides by the reciprocal of 3. The reciprocal of 3 over 1 is 1 over 3. Well, if you multiply the left side of the equation by 1 over 3, you have to multiply the right side of the equation by 1 over 3. Equal opportunity here. And what we're going to do, 1 over 3 times 3 over 1 becomes 1. It cancels out to the number 1. 1a, or simply a. Happy a. 12 times 1/3 is the same thing as 12 divided by 3, and that equals 4. We'll get the same answer, but we just have quicker ways of doing it. But it's all based on this concept right here, the multiplicative inverse property. What is the reciprocal of a? 1 over a. What is 1 over a times a, or a times 1 over a? It equals a fancy number, or a simple number 1. This time, the number will cancel out to the number 1. All right. State the multiplicative inverse of each one of these quantities. Easy stuff, guys. At least it starts off easy. What is the multiplicative inverse of 3 over 8? 8 over 3. We're just looking for the reciprocal, man. Don't make this harder than it is. What's the multiplicative inverse of -2? We're not changing the sign. It's still going to be negative. But instead of -2 or -2 over 1, it's going to be a -1/2. I need to talk about this. There are 3 ways you can write a -1/2, and all 3 of them are correct. You can say -1 over 2 is equal to 1 over -2, which is equal to negative, out front, 1/2. If it's coming from a book or a computer or a printer, the standard default way of writing the negative sign is out in front of the fraction. Oh man, I hope I didn't mess that up. That's a -1/2. I think I messed that up, got that line too close. We usually write our negative signs on top, but I've seen them written on bottom as well. I know there's another teacher that it says, oh, don't leave negatives on bottom. I've just never found that in any type of research that I've done. It's okay on top or okay on bottom, but what you cannot do, if it is a negative number, you cannot put it on both top and bottom, because now we have this situation where we have a negative divided by a negative divided by a negative, and then it'll become a positive answer. We don't want to change its sign. We just want to write the multiplicative inverse of it. Now this one's a little more difficult, but if you know how to read this, instead of saying -0.2, this is -2/10. What is it? I'm going to say it one more time. It is -2 over 10. That's its fraction equivalent. Now, you're going to learn in this class, always simplify. S-I-M-P-L-I-F-Y. Always, always simplify. That means if you can divide these numbers by the same number, the same factor, then do that. They can both be divided by 2. That's the same thing as -1/5. Now, that's what this number is. I can squeeze it right down here. I want the multiplicative or reciprocal of -1 over 5. That's going to be simply -5. There's our answer for this last problem right there. All right, finish off with this saying here. Oh good, I kept it under 30 minutes. The reciprocal of 0. What is the reciprocal of the number 0? Well, think of how we took the reciprocal of -2. We wrote it over 1, and then we flip-flop bottom to top. If we flip-flop bottom to top, we're going to get 1 over 0. Hey, make sure you're awake. Guys, red alarms, just like the red flag, should be going off right now. This needs to be written as U-N-D-E-F-I-N-E-D. Undefined, undefined, undefined. What do we mean by undefined? We literally mean there is no definition that allows us to divide by 0. You can never divide by 0. Anytime you see divided by 0, stop, write that word, and move on. Oops. I hope you weren't too far off the page. I'll get it back. I'll get it back. I'll get it back. I got to get some better setups here. All right. So here's what we can say. You can divide. Let's go green. It's okay. Yes, you can divide into 0. You can divide into 0. In other words, here's my little saying. 0 on top is, watch it, 0 on top is okay. It equals 0. 0 divided by any non-negative, by any non-zero number, as long as you're not dividing by 0, then it's going to be okay. You can divide into 0 all day long, and the quotient, the answer, will always be 0. Now, let's go red here. You can never, ever, ever, ever divide by 0. Dividing by 0 will put you straight in math prison. 0 on bottom is no way. It is undefined. Zero on top is okay. 0 on bottom is no way. 0 on top is okay. 0 on bottom is no way. Now you need to know more than just that sing-song dance. 0 on top is okay. It equals 0. It is a number that we can agree with and live with. 0 on bottom, no way. Jose, undefined. Get out of there. That needs to be in your brain just like you know your own name. So anyway, stand by to see if we're going to have one more asynchronous lesson to finish off this week. I will let you know. I said by 7 p.m. I'll let you know by 3 p.m. today. All right, have a good day.